Hi, I'm Gary Parker of the ECA, and today we're going to use DesignGenie to look at the different types of final circuits we can use. Earlier on I designed this installation with numerous consumer units and distribution boards. Here I can see I've designed several final circuits. Let's zoom in and have a closer look. We've got a variable circuit for a socket, a fixed load for a light, a specific motor circuit, a distributed load for a lighting circuit, a ring final circuit, a control, and a spare circuit. Each of these circuits is designed in a very similar way, but do have some slight different quirks. The variable load, for instance, is designed in a very similar way to the fixed load. The main difference on the variable load is that you can choose to combine or have separate overload and overcurrent devices. In the fixed load, the protection devices must be combined in a single short circuit device. If we've designed a fixed load by accident and we want to keep it as a variable load, or vice versa, all we do is right click on the appropriate load and it will ask if we wish to change it from a fixed to a variable or from a variable to a fixed. Let's just change it back so I don't get confused. Here we have a circuit for a motor, which we design in a similar fashion to other circuits. The only difference is we ask more questions. For instance, the startup current for the motor, starting time, and if located in an EX area, a TE time. We also have the option for designing a distributed load, sometimes used for a street lighting circuit. This is a special circuit in DesignGenie which considers not only the final load but also something called the branch length. This can be best thought of using a street lighting system, where you have a large radial circuit with branches tapping off to the fixed loads at the end. This can sometimes be a tricky calculation to do manually, but in DesignGenie we use the same principles as we always do, picking our cable, picking our protective device, and working out the load. We simply tell it how many points they are, the distance to the first point, the distance in between the points, and DesignGenie totals that up, in this case 110 meters worth of cabling. We then tell it the branch length, in this case 1 meter. We tell it the load per point. DesignGenie will work out our total load for a single phase, or if we choose to have a 3-phase supply, and then we design our circuit to suit. We also have a special option for designing a ring final circuit, something that is commonly used in the UK. The only restriction on here is DesignGenie will limit our final load to 32 amps or less. So if I try and input a greater load, it will tell me that there's a problem and will automatically reduce the value. There is also a special tab in DesignGenie for a control circuit. This is exactly the same process of designing a circuit, but is often used where you only have a very small load. The only limitation we have on this is that it will be single or 2-phase. The last type of circuit we're going to look at is a spare circuit. This is designed in a slightly different way, in that we don't have to put any protective device information or any cable information in. We simply give it a name and tell DesignGenie whether it's single or 3-phase and the type of device and the component that is associated with it. There we looked at the different type of final circuits that you can use in DesignGenie. I hope that helped. See ya.